the graph of President Parabola during his assassination.
I already told you guys, it was just as far from my directrix as it was my focus.
Don't you talk back to me. Hyperbolas like me eat parabolas like you for breakfast. Also,
Why are you being so behaviorally unconventional and slightly strange? Why can't you just control yourself like me? Are you trying to make up for something? Like yourself?
you want me to kill you? Hey.
Oh, it's a known fact that my placement is directly related to x squared over 4p, where p is the distance from my vertex to my focus, so it couldn't have been me.
You should know, even though my partner's major radius is greater than his focal radius, it's opposite for me. My focus right now is to break you so hard, you don't know if I'm X or Y opening.
Come on, guys. We really need to focus. The problem at hand here is that we don't know which conic section committed the crime or what he or she will do next. So, I've written down a list of suspects that were seen at the assassination crime scene.
As you can see here, suspect number 1 is a hyperbola, much like myself. The equation given here, x over a squared minus y over b squared equals 1, shows that it is an x opening hyperbola. The transverse radius is smaller than the focal radius, and its eccentricity is greater than 1. It has 2 asymptotes that also cross the graph.
Oh hey, I know that guy. That's me. As you can see, all my points are the same distance away from my focus as they are from my directrix, which means that my eccentricity is equal to 1. And I can also be modeled by the base equation of y equals the quantity of 1 over 4p times x squared, where p is the distance from my focus to my vertex.
Our third suspect here is an ellipse, much like myself, very oblong as you can tell. Its major axis is always greater than its minor axis. It's a property of ellipses. And the focal radius... Hey! Dog, get out of here. Wait. Alright. As you can tell, the focal radius is calculated when using the major and minor radius as well. And the pointed director is very important for calculating the eccentricity, which is usually less than eccentric. I mean, come on. The equation for an ellipse is x over a squared plus y over b squared equals 1.
Wait, if you have these 3 conic suspects, then by taking the discriminant, it should be pretty easy to find out who committed the murder.
There's the rub. We don't know which direction the suspects were rotated in and how much because they already left the crime scene. It's not like I could have discriminated even if I wanted to.
Whoa, just take it easy, man.
Well, I was at the scene of the crime, and I can tell that the discriminant of the conic was pointing towards the lower backside of President Parabola.
It's not that simple. Even if we know the rotation, we have no idea if the killing occurred with the ellipse's major radius or the hyperbola's focal radius.
Yes, indeed. The Pythagorean property for ellipses should show that the major radius squared should be equal to both the minor radius squared and the focal radius squared. But it just doesn't add up.
But what about the hyperbola's Pythagorean property?
It's the same as the ellipse.
But doesn't that mean that the hyperbola would correctly follow its Pythagorean property of its focal radii squared being equal to its transverse and conjugate radii squared?
Yes, there would have to be the ellipse.
We know that it's an ellipse and the major radius is equal to 5. And since we already know how far away the directrix from the murder occurred, which was 10 units, we can determine the eccentricity to be 0.5. Wait, 0.5. All these characteristics match up exactly.
Ew! No, please, no! I'm a family!
You will lift
skeptical scum. Looks like you won't be completing the square anytime soon. Truth is, it was actually me.
Buckle your pants, buckle your pants. Pull up your socks and dance. Buckle your pants. Buckle your pants. Buckle your pants, buckle your pants. Hey, I said dance. Buckle your pants. Buckle your pants. Ladies, buckle your pants. Gentlemen, buckle your pants. Boys and girls of all ages, buckle your pants or they might fall down. Hey you, buckle your pants. Yes you, buckle your pants. Everybody, buckle your pants. But if you don't want to,